For this problem, problem number 42, I have f of xy equals y times inverse sine of xy. I want to first find the partial derivative with respect to y. I got y times inverse sine of xy. I am going to have to use the product rule for the derivative. So let's do f with respect to y, the partial derivative with respect to y. Now another way you could write that, there are several ways. I could write it, the partial of f with respect to y, like that. And I'm going to have to use the product rule, so I'll do it like this. The derivative of y is 1. Then we keep inverse sine of xy, and then plus, now I'm going to keep the y and do the derivative of inverse sine of xy. So the derivative of inverse sine is 1 over the square root of 1 minus the argument. It would be xy squared, the whole thing squared, xy squared. And then I need to do the chain rule. I need to do the derivative of xy, but with respect to y. So in that case, I'm looking at this and I'm thinking, okay, with partial with respect to y, the derivative of y is 1 and x is a constant. So you're going to have x times 1 right there. So I'll end up with x. That's the partial derivative with respect to y. On this problem, they want you to plug in 1 for x and 1/2 for y and get some numerical value. Here, I'll put equals x equals y, so let's do that. So the partial of f with respect to y at the point 1 comma 1/2 is going to be inverse sine of 1 times 1/2 plus y is 1/2, 1 over the square root of 1 minus x is 1, y is 1/2, that whole thing is squared, times x, and x is 1. So then you can simplify this, and this would be inverse sine of 1/2 plus 1/2. Now 1/2 times 1 is just 1/2, and this would be 1 over the square root of 1 minus, this is 1 times 1/2, which is 1/2. Square it and you get 1/4. So 1 minus 1/4. What's the inverse sine of 1/2? What angle will give you sine equal to 1/2? By the way, in radians. Pi over 6. That's pi over 6. Plus 1/2 times 1. Now 1 minus 1/4, that is 3/4. So that's the square root of 3/4. And this is probably enough. I know we could simplify it a little bit more, but I'm thinking for class time, I'll leave it at that.